Welcome back to this course on Fundamentals of Computer Architecture. The topic of this lesson is benchmarks. If you buy a new car, you usually go for a test drive. This is less common for PCs. Most people do not measure and compare the execution times of their workloads on different PCs before they decide to buy one. Instead, they rely on benchmarks. A benchmark is a program that is used to evaluate performance. Performance is usually not evaluated using a single benchmark, but using a set of benchmarks or a benchmark suite. What type of programs have been used to evaluate performance? 5 types of programs have been used to evaluate performance. These are in decreasing order of accuracy. First, real applications. These might be considered the best, but real applications often encounter portability problems. As a result, very often some important activity has to be eliminated. Second best is to use modified or scripted applications. There are 2 reasons why applications are often modified before they are used as benchmarks. The first one is to enhance portability so that they can be executed on multiple platforms. The second reason is to focus on a particular aspect of system performance. For example, to create CPU-oriented benchmarks, the input-output operations are typically removed. Furthermore, scripts are used to reproduce interactive behavior, such as the user reacting to a mouse click. The third best option is to use kernels. These are small but key pieces from real programs. These kernels are key because they typically consume a lot of the total execution time. 2 very well-known examples of kernel benchmarks are the Livermore loops from the Lawrence Livermore National Laboratory and LinPack, which is used to rank the fastest computers in the world, the top 500. Kernels are nice because they are small and therefore you don't need to develop a compiler to test new features. But they are not representative of real programs and therefore they are best used to isolate the performance of certain features. The fourth option is toy benchmarks, such as Quicksort, the sieve of Eratosthenes, which is illustrated here, etc. They are small and easy to understand, but they are not useful to evaluate performance because nobody runs these programs. The fifth and probably the worst option is synthetic benchmarks. These are not real programs, but typical instruction mixes such as 40% additions, 20% loads, 10% stores, etc. Well-known examples of these are Whetstone and Drystone. Nobody uses them anymore, and when you are my PhD student, you should not use them too. As mentioned before, a benchmark suite is a collection of benchmarks that measure performance with a different variety of applications. The most successful attempt to create a standard benchmark suite is SPEC. SPEC is the acronym of Standard Performance Evaluation Corporation. SPEC is a very active corporation and I invite you to go to its website to learn more about it. SPEC focuses on CPU performance. It focuses less on other performance aspects. The current generation of the suite is SPEC CPU 2006. It consists of 12 integer benchmarks, CIN 2006, and 17 floating point benchmarks, CFP 2006. The current generation is already quite old, from 2006, but SPEC is currently looking for applications that could be used in the next CPU-intensive benchmark suite, which is currently codenamed SPEC CPU V6. This table here, which is taken from the textbook, shows a brief history of the SPEC CPU benchmarks. I will not explain this table in detail, just mention a few aspects of it. First, there have been 5 generations. The first in '89, SPEC 89, and the last one, the current one, in 2006. Every 3 to 6 years, a new generation was released. The reason for that was that what took quite some time, a couple of hours or so in a certain year, only took a few minutes to execute 3 to 5 years later. Now, single-core technology hasn't become much faster since 2006, which might be the reason why SPEC 2006 is still around. The second interesting fact in this table is that there is one application, the GNU-C compiler, or the GNU compiler collection as it is called nowadays, which has been in every SPEC generation. All other applications from the first generation have been replaced. Third, many SPEC generations included a benchmark performing compression. Compression in SPEC 92 and bzip2 in SPEC 2000 and SPEC 2006. EQN TOT is not a compression benchmark, but a benchmark generating truth tables from Boolean expressions. The fact that several benchmarks are in the same row does not necessarily imply that they are from the same domain. Fourth, image and video compression is also an application domain present in several generations. Integer JPEG or iJPEG in SPEC 95 and H.264 Advanced Video Decoding or H.264 AVC in SPEC 2006. These are all integer benchmarks, meaning that the applications mainly process integer, but most benchmarks in the suite are floating point benchmarks, which are highlighted here. SPEC CPU 2006 is aimed at CPU performance. They correspond to real programs that have been modified for portability and to minimize I/O. Other SPEC benchmarks include graphics benchmarks. For example, SPEC ViewPerf, which measures OpenGL 3D rendering performance. As can be seen here in this figure, which has been taken from the website tomshardware.com, the benchmark used is SPEC ViewPerf 11. Also, the benchmarks released by SPEC Application Performance Characterization Group or SPEC APC Group make extensive use of graphics. Finally, there are benchmarks that are representative of server applications with a significant amount of I/O activity. For example, SPEC SFS, which is a file server benchmark, and SPEC Web, which is a web server benchmark. The title of this specialization is High Performance and Embedded Computer Architecture. Unfortunately, benchmarks for embedded computers are less developed than desktop and server benchmarks. Because of this, most designers of embedded systems devise benchmarks that reflect their applications. One attempt for a standard benchmark suite in the embedded domain is the EDN Embedded Microprocessor Benchmark Consortium, abbreviated as EEMBC, but to be pronounced as Embassy. It consists of kernels and benchmarks from 5 application domains. Automotive, industrial, such as finite and infinite response filters. The consumer domain, such as JPEG, compression and decompression. Networking, such as open shortest path first. Office automation, such as dithering. And telecommunications, such as the fast Fourier transform and Viterbi decoding. Here are the main points I would like you to take home. First, there are many aspects to computer performance: latency, throughput, availability, scalability, performance per watt, and so on. Computer architects typically focus on CPU time, since that is the time they try to improve. Second, SPEC has been a very successful benchmark suite for desktop computers. Not as accepted, but still quite often used in the embedded domain, is Embassy. And finally, some test yourself questions. This time I will not provide the answers to these questions. The answers can be found somewhere in this video lecture. This concludes this lesson. Thank you for watching. In the next lesson I will explain how performance can be summarized when there are several benchmarks. Stay tuned.